When a string is pulled tight and plucked, it naturally vibrates at a natural frequency that's dependent upon the tension in the string, the length of the string, how thick it is, its diameter, and what it's made out of, its density. If you take a string like this and you hold it up close to your ear and keep a constant tension and pluck it, but pull out string as you keep plucking it, you'll hear a change in the pitch that's produced by the vibrating string. As the string length increases, the pitch that you hear decreases. We get a lower frequency sound with a longer string. If you keep a constant length but change the tension, how tight you're pulling the string, when the string is loose, you hear a lower frequency, and when the string is tight, you hear a much higher frequency. So what is it about the string that makes a longer string give us a lower frequency, lower pitch, but a tighter string give us a high pitch, a higher frequency? The key to understanding this is to think back to standing waves. The string itself, when it's plucked, produces a standing wave. The vibration in the string produces a standing wave with nodes at each end. That effectively makes this part of the string one loop. If we remember that one loop is half of a wavelength, then the wavelength of the sound, or the wavelength of the vibration in the string, will be double the length of the string. So that makes sense to think as the string gets longer, the wavelength increases. Well, when the wavelength increases without changing tension, we have a longer wavelength, which gives us a lower frequency because the speed of the wave in the string remains constant. The speed of the wave in the string is dependent upon its tension. If we don't change the tension, we're not changing the speed of the wave. But by changing the length, we are changing the wavelength. Since frequency equals velocity divided by wavelength, the longer the string is, the longer the wavelength, which makes our denominator get bigger. So the frequency that it vibrates will be the speed over the wavelength. As that wavelength in the denominator gets larger, the frequency of vibration gets shorter. So lower frequency gives us a lower pitch with a longer string. However, if we keep a constant length, we're keeping a constant wavelength. The wavelength of the wave in the string will be twice as long as the string. By changing the tension, we're changing the speed of the wave in the string. Well, since frequency is wave speed over wavelength, then if we don't change the wavelength, which is our denominator, but we change the velocity, which is the numerator, by changing the tension, that will change the frequency of vibration. Therefore, frequency is wave speed over wavelength. The larger the wave speed, the higher the frequency. So as we pull the string tighter, we make the speed of the wave in the string increase, which makes the frequency of vibration increase. So tighter strings give us a higher pitch, and longer strings give us a lower pitch.